Okay, so here we are, angle versus period, lab write-up. How does the angle of the pendulum affect the time it takes to complete a full cycle? Actually, I think I changed that, the period, which is the affect the period, the time it takes to complete a full cycle. Okay, so we did the experiment, collected our data using the period timer. We activate that, push play. It tells us that that's our number. And so all those numbers go in the data table down here. I've already filled them out, and I'm not going to do a hand drawn. I'm doing this video to show you how to use the computer to make a graph. So I'm going to select this entire thing. And it's really important that we don't write the units in here or the computer will get confused. If we write degrees or anything in here, that's why I guess you could put it down here. Degrees, time. Okay. So that way it knows, or whoever looks knows that this is in degrees and time. So here's how you do it. You're going to be amazed at how easy this is. You copy the table, go to Google Sheets, open a new blank sheet, and I'll go on the second line and I'll paste this data table. And I'm going to shrink it a little bit by swiping across the top. This is not necessary, but I think it might 75, make it a little bit smaller. And personally, I like these to be centered. I'm just doing some unnecessary things. You don't have to do what I'm doing. But here's the thing. The numbers that matter are in these cells. So I'm selecting those cells. And then you're going to, while that's selected, you're going to go up to insert and say chart. And really, there it is. That's it. You can reposition it. I think I'll park it right there and I'll make it a little bigger. But there it is. Let's take a moment to understand what's going on. You can do adjustments. You might want to do adjustments where this shows 5, 10, 15, 20, but the information is essentially there. So let's see, if we wanted to, I could stop this video right now, but if I want to edit the chart, okay, so over here, let's see, what do we got? Chart title. I might change this to say angle versus period. And the angle is the independent variable, so I'm going to put IND. I'll take away the degrees and say for the period is the dependent variable. And I think I'll center it so you've got some control over this. And now let's see, title color, I think I'll leave it like it is. Now if we click series, and like I said, we could stop just right there. If you just stopped there, it'd be fine. But I'm just exploring some of these options. Let's see, trend lines, data error bars. No, trend line. No, don't do that. Data labels. If you click data labels, that's actually writing the number at each of these points. And I think there's a way to form data point. I'm not sure if I'm looking for, what is that? No, let's undo that. I was trying to find, point size. There it is. if you tell it to have a point, now you can actually see, those little dots that we would have made by hand. I do like that. Let's, in fact, make it a little bigger. That looks good. Now I can see. But what I think I would also like to change this axis to be 5, 10, 15, 20. Not necessary, as I said. You could just stop already and it would be good. But horizontal axis, let's see if we can figure out how to get that. Treat labels as text. Yes, I like that. Just by clicking treat labels as text, now I got 5, 10, 15, 20. That's good. Now what about, I can close up this horizontal axis and click vertical axis. Looks like it's affecting the horizontal axis. Axis line. I like the axis line. Yeah, let's do that. So that looks really good. And the only thing else that pops into mind is grid lines. I think let's select horizontal axis, major ticks. Yeah, let's put the major ticks. And let's see, where are... let's do vertical now. And minor grid lines. What's that? Major ticks. Yeah, there. Now major ticks is enabled. And let's do minor also. Yeah, I like that. 5, 6, 7. That doesn't, that's in thirds. I don't know if I like that. Let's not do minor. What I was hoping for, though, is get some vertical lines. So how would we get that to happen? Major step. Minor count. 4. No. I don't know what that even did. That was on 2. Minor grid lines. See, I would have thought that would... Anyways, this is looking real good at this point. Let's go ahead and stop at this point. And there you have it. That's how easy it is to turn a data table into a graph. But yeah, there's something to be said about understanding the height of this is 1.6. So if this is 1.5, if we divided this up into 1.6, 1.7, 1.8, 1.9, then it would make sense that this is in the right height. And it's gradually increasing. Once we get up to here, we've gone past the 1.7 mark, getting closer to 1.8. All right, that's how you do it. Pretty easy. One final step is in the last video I showed up to this point where we created this graph. And if you remember, it was ready to go right away, but we added some features like, the points and the specific labels, title it, and all that sort of thing. Anyways, what I want you to do is click on the graph, like up in this empty area. Don't click anywhere else or it might think you're trying to edit something. And just go Control C, or if you're on a Mac, Command C. Then jump back over here and click where it says graph and just paste it. Then it'll ask you, do you want it to be linked to the spreadsheet? Which means later if we went in there and we changed the data table, it would update here. I'm going to hit paste unlinked. What this I think also means, if you link it to the spreadsheet, then if you deleted this spreadsheet out of your Google Drive, it might annihilate your graph. So I'm just going to hit paste unlinked. And there it is. Voila. Looks nice. Okay, I thought I was done, but there's one more thing we need to do. Write the conclusion and sources of error. The conclusion is, from the data table, from the graph, we can see that the values are going up just a tiny bit. So as we increase the angle from 5 to 50, the period increases, but just a tiny bit. If you take a look at our hypothesis, it's if I release the pendulum from greater angle, the period will increase. So what we want to say is, notice the guidance says, state whether or not the data supports your hypothesis. Pretty simple. Let's just do that. Let's say the data, excuse me, I need to take away the bold. The data did support my hypothesis, but just barely. I think that's fair to say. So we've done it. We said whether the data supported the hypothesis or not, but then we also need to restate the hypothesis in a simple sentence. So what we'll say is basically what we set up here. This is kind of in a real formatted approach. It says, as you increase the pendulum angle, the period increases. So we say, as I increased the angle, period also increased just a little each time. Right. Now, for sources of error, we did the experiment in the computer, so there were a lot less errors, sources of errors, than there would be in real life. When we do these virtual labs, I want you to pretend or imagine that you actually did them in real life. And if you did them in real life, I think one of the hardest things to control would be starting and stopping the timer. Starting and stopping the timer at exactly the moment you release it and exactly the moment it returns to its original position. That would be the biggest challenge. Another challenge would be releasing the pendulum from the exact angle. That would be a challenge. You could also imagine that any change in the density of the air around the pendulum, like even just you breathing near it, could actually influence. So density of air, density of pockets of air, and any movement of air around the pendulum, that would affect things. Also, friction at the pivot point. So when you're writing sources of error, for me, I basically will give you full points if you just name 2 or 3. 2 is like the minimum, but I would like 3 or more. You don't have to go too far beyond 3. Just hit the big ones. And for this lab, those are the things that I would definitely think of as sources of error.